Standard 1.6, finding coterminal angles in degrees and in radians. Before we get into how to actually do this, let's talk about what coterminal angles are. So suppose we have an angle sketched here. On the coordinate plane, okay? And when we're finding coterminal angles, we're finding angles that basically have the same terminal ray, but are angles of a different size. So for example, if I started at the same initial ray, but went all the way around once, and then continued some, I could have the same terminal ray. Or if I started at the initial ray, but went in the negative direction, I could have the same terminal ray. And so all three of these angles, the one with the red arrow, the blue arrow, and the green arrow, they're all terminal, but they're all of a different size. Let's put an actual angle measurement on this angle. So suppose this angle was 50 degrees. Now we can find coterminal angles by adding and subtracting full rotations, because if you add a rotation, you're basically at the same place you started from. If you subtracted a rotation, again, you're in the same place that you started from. So if we're at 50 degrees and we add a full rotation, that's what we see here in the green. We have a full rotation plus essentially what we did here in red, right? So 50 degrees plus 360 degrees ends up being 410 degrees. So 410 degrees is coterminal with the 50 here. We could also start with our 50 degrees and go in the opposite direction. So subtract 360 degrees. 50 minus 360 is negative 310 degrees. So both 410 degrees and negative 310 degrees are coterminal with 50 degrees. And again, the way to find coterminal angles is to add or subtract a rotation or many rotations. And a rotation when we're in degrees is 360 degrees. So we can add or subtract 360 degrees to find coterminal angles. Now let's suppose we're in radians. So again, let's have an angle here. Let's make our angle 2 pi over 3, which is in the second quadrant. And we could start here at the same initial ray, complete a full rotation, and then add another 2 pi, and we'd have the same terminal ray. So if we're adding a rotation, in radians, one full rotation is 2 pi. One rotation is equal to 2 pi radians. So we're going to add or subtract 2 pi from our given angle to find coterminal angles. In this particular case, 2 pi over 3 is our given angle. We can add 2 pi to find one angle coterminal with it. Now, this becomes a little bit more tricky because we're adding numbers that don't have common denominators. And you need to have a common denominator when you're adding numbers, some of which might be fractions. So let's think about this. We can take 2 pi over 3 and leave that alone. But we have to add something over 3 that's equivalent to 2 pi. 6 pi over 3 is equivalent to 2 pi. So really we can convert 2 pi over 3 to 6 pi over 3. They're equivalent. And that becomes 8 pi over 3. So 2 pi over 3 is coterminal to 8 pi over 3. Now if you're having trouble with the adding of fractions, let's see how we can do it on a calculator. If we have 2 pi over 3, we're just going to work with the numerical part of this, not the pi part. Let's take 2/3 for 2 pi over 3 and add another 2 pi. Well, we get that decimal, and if we convert that to a fraction, that becomes 8 over 3, and then we can just attach the pi back on. We can treat it like a variable, so 8 pi over 3. Now we can also get coterminal angles by going in the opposite direction. So suppose we start at the same initial ray, but went in the negative direction to find an angle that was coterminal with 2 pi over 3. So now we're going to subtract 2 pi rather than add 2 pi. So we're starting with 2 pi over 3. Again, to get coterminal angles, you want to add or subtract rotations. Let's subtract a rotation this time. So we're subtracting 2 pi. Again, you need a common denominator, so 2 pi over 3 minus, and we established 2 pi was equivalent to 6 pi over 3. And if we subtract, we get negative 4 pi over 3. So negative 4 pi over 3 is also coterminal with the original 2 pi over 3 and the 8 pi over 3. If you're having trouble with that, arithmetically, use a calculator. So we're starting with 2 pi over 3. We'll leave the pi alone. We're going to treat it as a variable. So we'll have 2/3 there. Minus 2 pi, just minus 2. We get that decimal, convert it to a fraction, to negative 4/3, and we'll attach that pi back on. So to find coterminal angles in radians, you're going to add or subtract a full rotation. In this case, you're going to add or subtract 2 pi. So in degrees, you're adding or subtracting 360. In radians, you're adding or subtracting 2 pi. That's how you find coterminal angles in either degrees or in radians.